Welcome, guys, to September 17th. It is Tuesday. Oh, Lexi, for this link down here to Discovery Ed, yeah, just sign in with Google, and that's for Discovery Ed. So I know you guys don't have curriculum there, so you only go in occasionally, but just click on sign in with Google, and that would take you right to the enrichment thing, the match, guess the element. And hello, Amani, welcome. And Tamira, welcome. Tyrese, good to see you. And so today we're going to be talking about chemical bonding. And so I thought it'd be good to review a few things about elements before we started. And you guys can use our quiet work time to work on that as well. Just a reminder about parking it to participate in class. You guys are attending. Make sure you read and respond to emails and complete all your assignments. Thank you guys for always being respectful and courteous in class. Remember, if you do need to step away, there is a step away button. So make sure you click on your gear and pick step away. It's under other tools. And if you can't hear, click the refresh button on that same spot. So we'll start here by doing a knowledge check. And if you didn't know what Alka-Seltzer tablet was, I got a GIF of it up there. So use your emojis. And remember to show me that you're participating, even if you don't understand. Go ahead and give me that red X, and that way I know you're here with me, but you don't know what's going on. That way I can help you. And it looks like we're almost 100% completion here. And it looks like nobody has picked turtle, and that's correct. Leaves on a tree produce chlorophyll to absorb the sun's energy. That is definitely a chemical change, so that is not the right answer. Let's look at smiley face. In the refrigerator, your sweet potatoes turn brown. So if you think back to yesterday, oh, Jackie, the emojis are down below me. They're in the bottom left corner, and there's a little button there for you to click, and then you can pick one. Oh, and I've got someone trying to come in, and the link isn't working. Whoops. Okay, so this is fifth period. So in your refrigerator, we talked about this yesterday and what air does to your food, right? Do you remember what that was called? Yeah, that was called oxidation. So when your sweet potatoes turn brown, that's oxidation, and that is a chemical change. So smiley face is not the right answer. Okay. And then for the OK symbol, there's a production of gas, so bubbles. And if you think back to yesterday, that was one of the things that showed that a reaction was a chemical reaction, the production of bubbles. Hey, Nick. That was quick. paint is just the color, but it didn't just turn color by itself. You actually had to just put the paint on top of it. And so that's why that is not a chemical change. That is a physical change. Right, so the correct answer there was the loudspeaker. So good job, guys. Oh, and something I didn't show you yesterday was this little video of these precipitates being formed. So this, let me turn my camera off. So this is, yeah, Lexi, that one was pretty easy. That one was silver chloride. This one's real speed. And what they're doing is they're mixing two different liquids together that are clear, and a chemical reaction occurs, and you get this solid formed. So this is silver sulfide, that icky brown stuff. This is barium sulfate. I love science too. I just thought these were so pretty. And this one is red because of the chromate in there. Silver compounds tend to be solid and they don't dissolve in water. So when you have a chemical reaction that produces a silver compound, it tends to precipitate out of the solution and become solid. This one is copper sulfate, and it's blue because of the copper. So I just thought that was cool. Just to show you a couple of chemical reactions that were precipitates. All right, so that was a good break. Oh, we only had one question today. Never mind. So today we are going to finish up with section 1B, and we're going to start section 2A. And we already did 1A, was completed a while ago. So we're just going to focus a little bit more on valence electrons. And good afternoon, Tamira. And Tyler, hello. I said hello to everybody. And Brittany, welcome, Brittany. Cool. What's next? So today we're going to look at chemical bonds, identify the 3 types of chemical bonds, and take a look at an electron dot diagram. So up here is a bond that's being formed. Can you all remember the 3 types of bonds? Yep, ionic was one of them. Hello, Nicholas. Covalent. And the third one is called metallic. So that's pretty straightforward. Anytime you just have something that's metallic, like the safety pin, just made out of iron, that's a metallic bond. So what's going on here in my little GIF up here? What's sodium doing? It's giving up its electron. And so what does sodium become when it gives up an electron? What is that thing called where it's got an unbalanced charge? Can you tell me what charge it has? Oh, okay. Yeah, Tamara, it is an ion. And what charge does sodium have? There it is. And you can watch the little GIF there. Let me just remind you here. Here's sodium. It's in group 1, right? So how many valence electrons does sodium have in group 1? It has 1 valence electron. And so it gives that valence electron away, right? So now it has more protons and fewer electrons. So it has more protons, so it's going to have a positive charge. And you can see that once this little GIF puts brackets around the sodium, it's got a little plus up there by it. So it's going to be positive 1 because it gave away 1 proton. Good job, Tamara. So the fluorine atom, what happened to its valence electrons? It gained 1. So it actually gained sodium's electrons. So now it has more electrons and fewer protons. So what charge does fluorine get? Yeah, it gets a -1 charge because it has 1 extra electron. So if you see anything that has a negative charge, you know it has extra electrons. If you see something that's positively charged, you know it has extra protons. And that's my other question. Oh, what kind of bond is this if it's between ions? Yes, exactly. It's an ionic bond. So we look at those little bits of the word to figure things out. So what is the name of this compound that we've made up there between sodium and fluorine? What would the name of that compound be? And you might know of a similar compound that it would sound a lot like, and Therese knew that. Yes, sodium fluoride. So the IDE is going to be our ending of choice when we have compounds. And hello, Scotty. And hello, Demetria. I see you have an answer to the question, but I don't remember seeing your name before. Anyway, and Tamara, welcome. No problem. All right, any questions about this little animation on here? Okay. Okay, so we're gonna watch a quick little TED Talk on ionic and covalent bonding. And there are also interesting facts. So be ready when this is over to post something on the board. So sometime within the 3 minutes of video, make sure you jot something down, and that way you can share that with the group, because we'll put this down on the whiteboard, so when we're done, we can fill it out. Okay, here we go.
Most animals don't have rhymes. Instead, they advance to
right, there I am. Let me put the whiteboard up so you can add something on there. So use the little type feature to type something in one of the three areas. Oh, I clicked unlock and it didn't unlock. You should be able to now. No, okay, I'll go through and unlock everybody individually then. It's awful. All right, I'm done up to Y, J, K, L, M, S, T, T. I'm still working on the T's. A lot of T names in here. W and Z. All right, so everyone should have the ability to write on the whiteboard now. All right, I don't see any more popping up there. Yeah, Nick put his in the chat there. So I really like this, that co means two. And so they will share that pair. Excellent. We've got the attraction between two ions. That's ionic is between a nonmetal and a metal. I thought that was interesting about DNA being covalently bonded. Oh no, Zakaya. No problem, Nick. It might be my fault for not giving you permission. See, Nick, I skipped over you somehow. So groups of elements, y'all, this is one of those vocab words that sometimes will mess you up if you don't know that a molecule is actually a covalently bonded group of elements. Just to make sure you keep that with covalent, I'm going to put it over there under covalent. All right, and there can be more than just one bond for each element. Excellent. And always remember, it's just the outermost shell electrons that can form bonds. Oh, Tamira, I think that is a very interesting fact, but just to make sure that you know it's covalent, I put it under covalent. No worries. I think it could go in both places. In fact, if I knew how to copy and paste it, I'd put it in both of them. So what are these outermost shell electrons called? Yeah, those are our valence electrons. Excellent. And so hopefully that gives you an overview of what you're going to be looking at today. I do just want to remind you that this check for understanding part of it is very important, because this is where you will really see if this was effective for you to watch the lesson, do the instruction. This is your main important thing to see if you learn what the instruction told you about. So when you are ready for the breakout room, you can give me a green check. And if you want some enrichment because you're ahead, please stay here. I've got some enrichment opportunities for you. Carbon. Excellent, excellent. So that was some fun practice. We did the discovery education practice while you guys were working. So if you want to practice a little bit, you can grab that link, which is on the note board. Any questions about chemical bonding as you went through the lesson? Any questions about ionic bonding? And this PowerPoint is available. You click those 3 white lines on your whiteboard, and you can go to my presentations and look at it on the whiteboard, or you can go to my attachments and download the PowerPoint. Yes, when you have covalent, you can, covalent, here we've got oxygen to carbon with a double bond. And then you could have the carbon bond to hydrogen. You could bond a hydrogen off of this oxygen. You can put nitrogen on there. Any nonmetal you want can go on there. Oh, you're welcome. So questions about covalent bonds, or I can go back to the ionic ones. All right. So I have one more. Back to my whiteboard. Okay, there we go. Didn't want to cover up our discussion today. That is not what I wanted to do. I wanted to move that down there. Okay, so fill in the blanks, and the vocab words are at the top. Oh, did it lock back up? Horror of horrors. Oh, goodness. All right, so what do you think the first one is? We'll just do this in the chat. Oh, someone's got, Nick, let me just unlock yours by yourself on here. Someone's got it. Okay, Nick, you should be good to go. So the outermost shell of an atom is the valence shell, definitely. Tamira is locked. Not anymore, Tamira. Oh, you can't hear me because I didn't turn on my mic. Yay, go me. You can always look up by my name and see that my mic is green if it's on. Oh, what a long day. All right, we have 5 minutes. Yeah. And look at all of these filled in here. How about the third one? A push or pull on an object. They're writing on the whiteboard, but Therese, there's problems. I just unlocked yours again. Nick, I've unlocked your whiteboard like 5 times. No, it's unlocked, Nick. And that would be a force. Thank you. The octet rule is the 8. Chemical bonds are the forces that hold the atoms together. And we're going to take a look real quick at an electron dot diagram. If that was too fast, you can download the PowerPoint. It has those answers in it, or look at it on the whiteboard. Oh, I'm sure you would have, Therese. I'm sorry. So I unlocked it, but I don't think we're doing anything else with that today. But I do have one more instant poll. Oops, I was going to clear them, but not anymore. What is the correct electron dot diagram for oxygen? Here's oxygen. Notice it's in group 16 or 6A. I know I haven't mentioned the 6A part. So how many valence electrons should it have if it's in group 6A or 16? And no, Therese, you didn't sound rude at all. No problem. All right, so we need 6 valence electrons. And so we can get rid of the OK symbol, and we can get rid of loudspeaker because they don't have 6 valence electrons. So the next question is, do electrons like to clump together and attract each other, or do they like push apart and they want to expand and get away from each other? And Tamira, nice job there. Tamira, you got the right answer. Lexi, good job. Isaiah, excellent. Excellent. So if I didn't call your name, maybe rethink this a little bit. And like Tamira and Lexi said, they want to push away from each other. Electrons all have negative charges, and so they're going to repel each other. And so they're going to spread out. So when we're doing these dot diagrams, we want to put 1 electron on each side, and then we start doubling them up. And let's see, Jackie, you got it now. Nick's got it. And Brittany's got it. Good job, guys, with the turtle being the correct answer. Yeah, I definitely agree with Tamira. If you didn't get it, that's why we're here practicing. And that's what this is. This is how you learn. You learn by practicing and doing. And oh, it skipped. There is the correct answer with the green check. Yes, always okay to make mistakes. I'll make my fair share of them too. As I did, I think I made several mistakes just today, but that's all right. We're all human. We're all here to learn, have fun, and enjoy school. So I hope that you guys enjoyed class today as much as I did. Oh, let me unannotate. So you can see my Rubik's Cube. I used to be able to solve a Rubik's Cube in 30 seconds, but that was back when I was your age, or maybe middle school, probably closer to middle school. Anyway, keep challenging yourself. Make sure you do that check your knowledge part on all your assignments, and I will see you guys tomorrow for our block day. Have a wonderful afternoon.